Good morning, students. So, the topic which we are going to study today is first the uses of radioactive isotopes, then what are the sources of harmful radiation, what are the effects of harmful radiation, how the nuclear substances need to be handled, safety precautions, and lastly the background radiations. Now, before going into all of these, let us first understand what is the meaning of radioisotope. Radioisotope is nothing but a version of an isotope of an element whose nucleus is unstable, Now you will say, okay, that is uranium nucleus is unstable, so is that becomes a radioisotope? Yeah, that is a radioisotope, definitely. That is uranium itself is radioactive. Now we want some substances who otherwise are normal, some elements who otherwise are normal, but their isotopes may be radioactive. Like for example, that is, I will enumerate the normal elements and I will eliminate the radioactive isotopes. Radioactive isotopes. So the first element, that is carbon 12-6. This is a normal element and the nucleus is pretty stable. Now, whereas the radioactive isotope would be 14 and 6. This is the radioactive isotope. Similarly, it goes for phosphorus. Phosphorus, as you know, the mass number is 31 and the atomic number is 15. Now, phosphorus 32 and 15 will become a radioactive isotope, will be a radioactive isotope. Now, similar thing will go for cobalt. Now, we know that cobalt 59 and 27, that is a normal this thing, but however, mass number cobalt 60 and 27 is a radioactive isotope. So, that is, these radioactive isotopes are either naturally found or they are being prepared by transmutation. Transmutation we have already studied in earlier classes, that is, transmutation is nothing but the transformation of a nucleus by bombardment of certain particles on it. So, without discussing anything further, we will go on to what are the uses of radioisotopes. So, that is, whenever we are going to talk about uses, I would be especially discussing about, I will write uses of radioisotope. So, the first use which I would be discussing is the medical use. The second use is the scientific use. And the third one would be the industrial usage. Now, what exactly medical use is there? Now, as we know that cobalt, I have just told you, that is the radioisotope of cobalt, that is mass number 60 and atomic number 27. So, it emits gamma radiation. Now, what will happen? Now, these gamma rays are used to kill cancer cell. The gamma radiation from cobalt 6027 is used to kill cancer cell. This is the first thing. That is, or that can be used to kill the malignant tumor. Tumor is the unwanted growth anywhere. So, in order to kill that, gamma rays from cobalt is being used. Now, apart from this medical use, this is the first one. Second one is also very important. That is, we will discuss about something called as traces. That is radioactive traces. So, what are these traces? The tracers are weak salt, radioactive salts of, let us say, NaCl or radioisotopes, or you can say radio ion Fe or radio iodine. So, these are weak salts of these radioactive substances when they are being injected into the body, or when they either flow with the blood, or they are being injected at a particular organ in the body, then we are being able to find out where the blood clots are there, blood clots, or even tumors could be found out by this. See, now these tracers, what will the tracer do? Suppose if this is our body, now suppose the tracers is injected, now it will go to the entire body, and wherever supposedly ear clot is there, now it will not go beyond this particular region. Now the radiations from these are being detected and are being studied, so that okay, we need to find, okay, where is the tumor, okay, then you can say that blood clots are there or tumor is there. Now this particular technique is also called as radiography. This particular technique is also called as radiography. Tracers are nothing but, you can say, the GPS. That is, supposingly if you are actually, there would be some girl students who would be going outside, and then in order that the parents feel that they are safe, so what they do is they put some GPS tracker on the mobile of the girl student or the boy student. I don't differentiate between girls and boys. So in order to check for the safety of them, so the GPS tracker has been installed. So similar to a GPS tracker, this particular tracers, radioactive tracers are there. they do the same function. They do the same function. Now coming over to the second use, this is called as radiocardiology. Sorry, radiocardiology. This is called as radiocardiology. Sorry, my mistake. Now second one is the scientific use. Now in case of scientific use, that is in order to study nucleus of certain atoms. So what has been done? That is particles, that is you might have studied about the Rutherford gold foil experiment, in which what was there? That is, we had one gold foil over here. Now the radiations from this particular elements were being incident, that is essentially helium nucleus, that is alpha particle, were incident on this gold. Now this radiation, depending upon the scattering of the radiation, this helium radiation didn't pass through gold, but it had scattered everywhere. So after studying of this scattering, of alpha particles, the nature, the size and other features of the nucleus are being ascertained by using this particular technique. Now there is another thing, that is, as we know about tracers for human being, now there are tracers also for plant. Now you will say, sir, what is the need for tracers for plant? Now you know that we are supposedly in plants also a lot of research has been going on, and now in order to study, okay, how is the absorption of a particular chemical manure, then this particular chemical manure is inserted either into the soil or into the plant, and the path of this manure throughout the plant is being traced by using plant tracers, which are also radioactive in nature. Okay, now regarding scientific use, the third scientific use, I will just erase this over here and I will write the third scientific use, or I will erase this as well. So the third scientific use is C14 dating. That is, see, we know that carbon, the radioisotope of carbon C14, now it will emit a beta ray and it will be transformed into nitrogen, which is 14,7 plus beta, that is 0 and -1. So and it would be surprised, you would be surprised to know that this radioisotope, that is 14(6), this carbon 14(6) is there present in our bodies. Now it has been constantly replenished in our bodies by various activities, and when a person or when a human being or an animal dies, now the replenishment of this carbon 14 is not there. So what will happen over the period of time, the carbon 14 in the body will keep on reducing and depending on after an organism dies, this C14 keeps decaying. The amount of C14 left in the body of the dead organism will tell us the age of the organism, or the similar technique is used to find the age of fossil or the age of rocks. So this particular technique is called as C14, carbon 14 dating of carbon 14. Okay, now this was the scientific use, and now coming on to the major one, that is the industrial use. So we all know that is first and foremost, we know that uranium 23592 is being used in nuclear power plants. 23592 is used in nuclear power plants in order to convert this nuclear energy into electrical energy. Now this is the first one, that is in nuclear power plant. Now what is the second one? That is, now you would be knowing about static electricity. Now static electricity is generated by friction. It is generated by friction between two bodies. Supposedly in a factory or an industry, there are two rollers which are sliding over each other, and let us say something is coming out of these two rollers. Then what will happen? There will be an accumulation of static charge on this particular thing. Now we will be using the ionizing property of the nuclear radiation in order to remove this static charge. So what is done is, normally the ionizing property of radioactive radiation is used to remove this static charge. So what is being done is, the radiation ionize air, and this will cause the static electricity to dissipate. That is, the static charges would be dissipated. Okay. Now the third thing is about, that is the ionizing effect of radiation is also used. Ionizing effect of radiation is used for preparing incandescent lamps. Incandescent lamps means you might have seen those very designer lamps on shops or something. So those lamps are incandescent lamp. CURIE. So these lamps which you might have studied, these are incandescent lamp, that is they grow during the night and similar to neon lights. Now this was the ionizing effect of radiation. And okay, now one more thing over here, that is, we know that the beta particles, supposedly you are owning, some of you would be owning a paper company or a plastic company. Now wherein the paper or a plastic sheet, this is a let us imagine this is a plastic sheet. Now we know that beta particles are having a sufficient only limited penetrating power. So beta particles are from any source, beta particles are incident on this particular film, plastic film. If now depending upon how many beta particles are emitted on the other side and depending upon the penetrating power of beta, the thickness of paper or plastic or metal is controlled by using of this particular arrangement. Okay, so these are the 4 important things. Now let us study what are the sources of harmful radiation. Let us study what are the sources of harmful radiation. And in this we will be studying about not only the radiations which are coming from the nuclear plants, but also the radiations which are coming from space, that is cosmic radiation, and also from the nuclear waste, So the topic is sources of radiation, So you know, okay, again 1, 2 and 3. Chalo. Now firstly the accidents which had happened, or you can say radioactive fallout from nuclear power plant. The second is the nuclear waste, and the third one is cosmic radiation. Now what are the accidents, nuclear accident which had happened and which had caused the radiations to go beyond their normal zone. So firstly there was an accident in 1979, that was a 3 Mile Island. This accident happened in 1979, it happened in United States. It was a partial breakdown of the nuclear reactor. Then whenever nuclear accident comes into your mind, the first thing you will remember is of Chernobyl disaster. That is the complete breakdown of the nuclear power plant which was located in Chernobyl. This happened sometime during 1982, and the harmful effects are still present over there. That is that area is still inhabitable. Now the other one is Fukushima in Japan. Because of the earthquake, there was a partial breakdown of this reactor, and because the Japanese are very disciplined so major casualty was been avoided because of this. Okay, so the earthquake had damaged the reactor in Fukushima. Now regarding nuclear waste, what is nuclear waste? That is the material which still emit radiation, but which is no longer useful in the nuclear power plant, which emit radiation, but it is no longer useful in nuclear power plant. Now these nuclear waste which are the fuel or the used nuclear rods, these are to be disposed properly. They have to be covered in the lead box and buried deep into the ground. There are different safety measures which are been imposed on disposal of this nuclear radiation. And okay, now the thirdly we will say about cosmic radiation. What is cosmic radiation? Cosmic radiation means, supposedly if this is the earth, now here we have sun. Now different rays or different radiations which come from the sun all the time, and not only from the sun but from different stars also different radiation all the time they come into the earth. Now this radiation contain high energy particles. These radiations contain high energy particles. Now only some, okay, more because of the earth's magnetic field, because of earth's magnetic field, most of these particles are deviated from the earth, but however some of them still come onto the earth, that is some gamma rays or some X-rays still come onto the earth, and knowingly or unknowingly we are being exposed to this. This is the third cosmic radiation. Now fourth one. Okay, now you would be knowing that is there is one place in France which is CERN, that is particle accelerators. So from here also some radiations do come out, and this is also one of the source of radiation. Okay, now the other thing, the third topic for today is what are the harmful effects of radiation. Herein we would be considering the short term effect, the long term effect which is irreversible, and the genetic effect. Okay, so I will write harmful effects of radiation. So harmful effects, as our book has been saying, that is there are three effects which we can categorize into, that is short term, the other is long term, and the third one is genetic. Okay, short term means this could be reversible, long term is irreversible, and genetic, that is the gene structure has been modified, so it passes from generation to generation. Okay, so that is there. So short term is reversible. Now as you know, that is first thing is diarrhea, or you can say diarrhea, nausea, then hair loss or sore throat. These are the effect when we are being exposed to nuclear radiation for a small amount of time. So, and after we are away from that, then these are reversible in nature. Only it happens during a short period of time. Whereas, okay, long term would be leukemia, or the other would be skin cancer. So these are the long term effect. If we are continuously exposed beyond a certain level of radiation, then we might get leukemia or skin cancer. Now the third and most important is the genetic, that is the genes are altered, and this abnormality or this defect has been passed from one generation to another. Now we are considering of harmful effect of radiation, although those just out of topic, which is also given in our textbook. Now we would be studying about the harmful effects of X-rays, or let us say CT scans or this thing. Now what happens is, if pregnant women are being exposed to X-rays, then it may affect the child in the womb. If pregnant women are being exposed to X-rays, then it may affect child in the womb. So with doctor's advice only this is to be carried out. But however, okay, that has been decided. So let us study what are the safety precautions. Safety precautions mostly in nuclear plant. As given in our book, that is the nuclear power plant should be located, its location is decided so that it is far away from the city. But however, now the city has so expanded, that is even the power plant, the first nuclear power plant set up by Homi Bhabha, it is still comes under that is, it was located in Chembur, and it still come under Mumbai. So leaving that topic apart, what is the safety precautions while using nuclear energy? Okay. Now, the first and foremost is shielding. Shielding means what? Even if nuclear power plant is there, do you know that Chernobyl power plant had a, you can say, very thick layer of concrete outside its plant and very thick iron sheet also on it. But the nuclear explosion was so immense, was so disastrous, that is the iron lid was literally shattered into pieces, and all the nuclear radiation had come out. So that is the shielding to be done by using lead or thick concrete. So this is the main thing. First. Second thing is about maintaining distance. So if the distance is maintained from the nuclear source or the radiation source, then that is always better. Thirdly, it is the exposure time. The exposure time should be minimum, the exposure time to the radiation. So the harmful effect depends upon how much distance we are and how much is the exposure time. Now the fourth thing is, now even if certain operators, that is who are working in nuclear power plant, they have to go in order to handle the fuel, and that is normally okay. By the way, the fuel handling is robotic in nature, that is robotic fuel handling. There is no manual intervention, so this is minimal. But however, if in certain cases, if some personnel has to go in order for near the fuel or something, then they have to use lead coated aprons. They have to use lead coated apron and lead tongs for handling of nuclear fuel or nuclear waste or something of that sort. Now, even in nuclear power plant, the level of radiation is being monitored continuously. The radiation level is monitored continuously, and for those persons who are being exposed to nuclear radiation, there is a certain exposure limit, or they have a certain material which is there on the lead apron. Now if there is a color change of that particular material, that means the exposure time of that person is beyond the safe limit. So firstly, what are the safety precautions? That is, the time for exposure should be as minimum as possible. The distance from the nuclear radiation should be as greater as possible. Thirdly, the shielding should be as greater as possible, and this will result in the radiation exposure to be minimum. Okay, so this was the fourth topic, and the fifth topic is of the background radiation. Now we will discuss a few the other topic, a छोटा सा topic, which is background radiation. What are background radiation? That is okay. Now, firstly, knowingly or unknowingly, we are being exposed to certain radiations, which are certain radioactive radiation. Now, what are those? Okay, let us study background radiation. So, initially we had studied about cosmic radiation. That is, even if you try so much, then also there will be certain radiations which would be coming from outer space, that is from stars or from sun, and which would be falling on us. So that cannot be avoided. Now secondly, radiation from rock and soil. Radiation from rock and soil. Now these radiations which come from rock and soil, that is they are due to decay of uranium. And now I don't know whether this soil could be there in the walls also. So there would be very slight radiations coming from the walls, from the walls inside the building. Now the thirdly, there are nuclear, okay. Now there are certain radioactive isotopes which are there also there in our body. That is, first, so you know, carbon 14 is there, which is a radioactive isotope in our body. Secondly, potassium 40 is also a radioactive isotope which is also found inside our body. Now fourthly, that is the medical source. That is, we are talking of harmful radiation, and okay. Now remember, that is X-rays or CT scans. They contribute to a large proportion of artificial radiation. So this thing would be generic. If you are being told by different doctors to do X-rays twice or more than 2 times in a year, then consult, have a second opinion, and get it done. Okay, I think you have understood all these topics. So thank you, and keep studying.